Alright, back from my break. Everything happens in the middle of times when you don't need it. Number 19. On number 19. I actually meant to do every other problem. For some reason, it's not happening. Rewrite in log form. Well, that's base. Argument 10. No. Exponent is a log of base 10 of argument 105. It's actually pretty easy. I don't know, but if you don't have a map, it could be pretty hard. Who knows? Write in exponential form. So it is base e. Let's see. Base e to the power of 3, because log equals the exponent 3. And the only thing I didn't use was x. So that has to be it. That's why there's so many problems, because a lot of this stuff is pretty easy. What's the solution? Well, let's figure that out. 21. So if we write number 21 in exponential, 4 to the power of 2, 4 to the power of 2 equals the argument, though, if the answer is 16. Okay, we'll skip 22. Well, 2 to the power of negative 1 is 1/2, so geesh. That's just super easy for me to do. Okay. Basically, you just have to rewrite this in exponential form. 23. When you rewrite it in exponential form, is the base 10 to the power of the exponent 1. The answer is just 10. Oh, 24 is the first hard problem. 24. If it says f of x is 5, so we just, instead of writing f of x, I'm going to write 5. So we start with 5 equals log base 2 of 9x plus 2. It's pretty important you understand that when you have a log equation, you have to solve for x. It's like 99.999% of times you will convert it to exponential to solve it, because 2 to the power of 5. Because doing logs is impossible unless you have a calculator. 2 times 2 times 2 times 2 times 2 times 2, or 2 times 2 times 2 times 2 times 2 times 2 is 32. Subtract 2, subtract 2. 9x equals 30. Divide by 9, divide by 9, and we have x equals 30 over 9. But you can reduce that by 3. 30 divided by 3 is 10. 9 divided by 3 is 3. 10 over 3. Alright. 25. 25. It is the basic log equation, which has an hk of 0, 0. And because this is a log equation, we know that the vertical asymptote goes 3, 0, 0. So we're looking for a vertical asymptote 3, 0, 0. It's not this one. It's not this one. It could be this one, and it could be this one. So it narrows it down to C and D. C or D. C or D, because those are the only ones with vertical asymptotes at 0, 0, 3, 0, 0. So now we have to change f of x equals log base 4 of x into y equals, we have to solve, no, we're going to have to change this into a exponential, because you can't do this without a calculator. You could go log base 4 or something with a calculator and t-table, but I'm going to show you how to do it without a calculator. Base 4 to the power of y equals x. There we go. And we're going to t-table. Now, we're not going to be plugging in values for x. We're going to be plugging values for y, because that's the easiest way to do t-tables. So I'm going to use 0 for y, negative 1 for y, and 1 for y. Another thing we have to remember is that 0, 0 is not a point on the graph. 0, 0 is the vertical asymptote, which says the graph can never touch the vertical asymptote, but it's always approaching it forever. First I'm going to 4 to the power of 0, which is 1, that's the easy one. And I'll do 4 to the power of 1, which is 4. That's the one. See, I'm just plugging in values for y. Now, 4 to the power of negative 1 is 1 over 4, so that's going to be really close to the graph. We're going to have to well, I'm going to look for 4, negative 1. I'm not going to look for 1, 4 because it's a little harder. So 4 to the right, 1 down. Between these two, which one has it? 1, 2, 3, 4 to the right, 1 down. Nope, there's no point there. This one, 1, 2, 3, 4, 1 down. Yep, it's right there, so it's definitely C. Domain and range. Uh-oh. What did I do wrong? Oh, 4 to the right. Oh my gosh, did I do that? That was supposed to be a positive one. Erase it, erase it. How did I make that a negative one? Should be a 4 to the right, 1 up. 4 to the right, 1 up. Woo. Luckily, I get multiple chances of guessing on this multiple choice question. If I narrowed it down to 2, I can get the answer really quickly. Well, that was it. Interesting. Okay. When we do the properties of logarithms, and this was property, what's it called? Product rule. We're just multiplying. If it's a sum of log, we just multiply the arguments 2 times z. I'm pretty sure the next one's going to be the exact same problem, similar problem. Okay, yep, r times r. Okay, so basically I'm typing in log, L-O-G, then I'm doing shift underscore, which gives me the base, which puts the cursor into the base, shift underscore, which is the button to the right of 0, just to the right of 0, and then I'm going to hit the 7 to put the 7 in there. I'm going to hit right arrow to get out of the base, and I'm going to write r times r. I can write r times r, or r squared. I don't think it'll ask. I think it has to be r squared, because I believe r times r would for sure be wrong. Nope. Okay. Then maybe it's r times r. R? Weird. R times r. R. I think the random number generator accidentally generated the exact same thing. So now you know, even though r squared was correct, it is not what they were asking for. So that's a glitch in the matrix. Rewrite as a sum, so log shift underscore to get to the base 6, right arrow 19, and we're going to put plus log shift underscore 6, right arrow x, enter, and that was pretty quick. That's why there's so many questions on this homework assignment, because you can just type it in really fast. ln 27 plus ln of e. Well, ln of e is actually 1, so you have to simplify this for sure. And that's one of the things that they do in the book too, so should expect that. ln of e, they're inverses of each other, so they cancel each other out. Log base e and e base e to the power of 1. Let's get over there. Suppose that log base 3, okay, let's do this, number 30. I'll do this on the switch. This work. So this is number 30. 30. Number 30. Log base 33, log base b of 33 is log base b of 11 plus log base b of 3, because it's 11 times 3 or 3 times 11 is 33. Now log base b of 11 is q. Log base b of 3 is p. So p plus q or q plus p. Let's put it in alphabetical order. P plus q. P plus q. There it is. That was an interesting one. Okay. Rewrite as a single logarithm. So I'm going to have to write some work here. 31. This is log base 7 of 2 over 8. This is a quotient rule. The negative log always goes into the denominator. 2 over 8. So that's definitely going to simplify to 1 over 4. To reduce it. Reducing fractions to simplest terms. Oops. Oh man. What happened? That's kind of annoying. Touch the pad. Log shift underscore base 7 right arrow, parentheses, 1/4, right arrow, close parentheses. There it is. Alright. Let's figure out what happened to this. Why are you giving me such a problem? It zoomed in on me. What did you do? What did you do? You cannot undo it, of course. There we go. View 100%. Alright. Somehow touching the mouse pad made it go weird. I'm using a tablet. Yes, let's select all clear everything real quick. Start on fresh slate. Alright. Use the power. Okay, I don't even need the show work here. It's just that 5, the power rolls of 5 goes to the front. 5 goes to the front. It's 5 times log shift underscore base 8 of x. Some of these are so easy, that's why this is a long assignment. Intimidating when you start, because you start with hard problems, but then later on you find out that these are actually quick and easy. Log base 3 of n to the power of 5. Power rule. Next question. Oh, this is a weird power. Okay, so it says use radicals. Alright, so this is normally x to the power of 5, 6, but we're not allowed to have a fraction. So it's going to be the 6th root. Let me find the 6th root button right here. We type in 6th root of x to the power of 5. 6th root of x to the power of 5 is the same thing as x to the power of 5 over 6. That's going to be a tough question to remember or get right. These are inverses, inverse slash opposites. They cancel each other out. Log base 7 of 7 base to the power of 71. Those are inverses. And inverses again. Inverses again. Inverses again. Alright, now we're going to rewrite this as a single logarithm. It's going to reduce too. Let me write this down. Number 39. 39. First, we're going to write it as a single logarithm, and then we are going to reduce the fraction. Okay, positive log 2 on top, positive log 5 on top, and negative log 6 goes on the bottom. Now, before I multiply 2 times 5, I'm going to reduce. 6 divided by 2 is 3, 2 divided by 2 is 1. So that is going to equal 5 over 3. Log base 8 of 5 over 3. Log base 8 of 5 over 3. (40) is the exact same thing. Now, after a while, you get really good at this stuff. The first one is x to the power of 5. Well, first we have to start with a fraction. I'm going to click the fraction button so that I don't have to worry about making a fraction. X to the power of 5. And to get the power, I'm using shift up arrow or shift 6, which gives you the up arrow, puts it up in the power. I'm going to hit the right arrow. Let's see, y to the power 2, because that's another positive log, and negative 4 ln z is a negative log, so it goes z to the power of 4 on the bottom. Right arrow to get to the right, and close parentheses. Whew, that was a big one. I think I could do this one. Now, same thing, type ln, and then we're going to start with the fraction here. Now, a to the power of 4 is the first log, a to the power of 4. The next log is b to the power of 1/5, which is the same thing as the 5th root of b, because the denominator of exponents is going to be the root of the radical. To the bottom, and c to the power of 3 is the final. There it is. This is 5 plus s minus t. 5 plus divided by, no. Definitely no divided by. That narrows it down pretty easily, pretty quickly. 6 plus x plus y plus z minus w. What is the equivalent expression? I'll have to type all that out. Log base 2. Nope, wrong base. Log shift underscore base 2 of 6 plus log base 2 of x plus log base 2 of y plus log base 2 of z minus log base 2 of w. Is that what they want? Yeah, rewrite it as more than one logarithm. 2 or more logarithms. Should be it. There it is. Fantastic. Same thing, the exact same question. Log base 4 of x. It's a positive log because it is in the numerator. Log base 4 of y. Same thing. And the rest are negative. Now this is interesting. The 16 can be reduced. Now, instead of writing right on the side, this is number 44. Instead of writing log base 4 of 16, because I know 4 to the power of 2 equals 16, this is going to simplify to it too. It's one of those things that will 2. So this one, 16, is going to change to just a 2, the log base 4 of 16. Instead of that, you would say 2. And log base 4 right arrow of z. That's, oops, it's negative. Almost messed up. Because those are also in the denominator, those are also negative logs, and that makes that a negative 2 also. Almost missed it. There's so many chances for making a mistake on this one, but we're almost done. Expand again. Expand and simplify. So log base 2 of 8, 45. Log base 2 of 8. Well, 2 to the power of what equals 8? Well, 2 to the power of 3 equals 8. So here we go. 3 is the first one, because log base 2 of 8 is 3. And then the second one is x to the power of 3, or 3 log base 2 of x. Oops, of x. Just like that. So the power of 3 moved to the front of the log. Same with the power of 4 moves to the front of the log, and the y is inside. And the power of 5 to the front of the log. There you go. It's really hard to type it in, so take your time. You don't want to mess up and have to retype that off from scratch. Make sure you save your work, because you never know, so you didn't save it until the very last second. Look at that, 100%. Okay. So that's what happens. I didn't mean to do all of them, but it just happens sometimes.